Good afternoon, and welcome to the Minnesota LTAP webinar on gravel roads, drainage, maintenance, and design webinar. My name is Jim Grothaus, and I'm the director for the Minnesota LTAP program. And we're here today for an hour to discuss some topics in drainage, maintenance, and design issues. We have three presenters with us today that are going to be discussing maintenance issues in the areas from an administrative point of view, an equipment point of view, and a supervisory point of view. And they'll be covering areas of good gravel, the importance of having a gravel road maintenance improvement plan, proper shaping of your gravel roads, equipment failures, equipment to use while shaping your gravel roads, and the impacts that gravel roads can have on your community. Our three presenters today will be Rick West from Otter Tail County. He's a registered engineer that has more than 35 years of experience in rural county highway department operations and management. He is presently serving as the county engineer of Otter Tail County, Minnesota. Our second speaker will be John Okeson, and he has more than 40 years of experience in operations, supervision, and management for rural county highway departments. He has served 20 years as a township supervisor in the state of Minnesota, and he's retired from the Becker County Highway Department as a superintendent after 42 years. He presently serves as a Becker County commissioner. So right there we have over 70 years of experience with today's event. And the baby in the community here, Corey Urich from Central Lakes College, has only 18 years of experience in gravel road maintenance and equipment operations. He's a heavy equipment operations maintenance instructor. He's been a superintendent and equipment operator and a site safety inspector with Strata Corporation here in Minnesota. He has 18 years of experience working with heavy equipment, including 10 years of experience in managing maintenance, operations, and operator training for heavy construction crews. As an instructor, his classes focus on safe and efficient operation of motor graders, bulldozers, loaders, and other heavy equipment. So those will be the three presenters today during the webinar. A couple things to note as we go through the webinar today. If you're watching this online, you have the ability to ask questions to us at any time. In the top left corner of your screen, there is an icon or a bubble, a conversation bubble. All you have to do is put your mouse up there, click on it, and then you'll be able to send an email. That email is sent to us here at the University of Minnesota. Mindy Carlson, the program manager for Minnesota LTAP, is collecting those questions, and then we will ask those at the appropriate time through the presentation. The presentation today has three parts to it again: an administrative point of view for gravel road maintenance and design, and we have a supervisory point of view as well as an equipment point of view. As we go through those three, at the end of each segment, we will see if we have any questions from the audience out there. We will ask those questions, get those addressed, and then move on to the next part of the webinar. At the end, if we have time, we will then also collect any other questions that are out there and summarize those and answer those for the audience. At this point, I'd like to welcome up to the podium, again, Mr. Rick West. He's the county engineer for Otter Tail County, and he'll be discussing the administrative point of view on gravel road maintenance, drainage, and design. So at this point, Rick, take it away. Thank you.
Thank you, Jim. Well, good afternoon, everyone. It's a pleasure to be here this afternoon. What I'm going to talk about, a little brief introduction on gravel roads, and get into developing a road maintenance plan. When we talk about gravel roads, about 1/2 of all the roads in the U.S. are unpaved. And a lot of those unpaved roads are a gravel surface. Minnesota has about 132,000 miles of roadway in the state, and that would make approximately 66 miles or 66,000 miles of those roads gravel surface. So it's a big part of the system in the state of Minnesota. When we talk about the importance of gravel roads, there's 4 bullet points of things that come to my mind. As all of you are probably aware, the majority of our trips and loads in our state begin and end on a local road, and a lot of those are on a local gravel road. They're important accesses for emergency services to the citizens and businesses, and they provide delivery of day-to-day services and products to those residents and businesses. And the fourth bullet, we talk about gravel roads, and something many of us that have been involved in gravel roads realize that they were never constructed to carry the traffic that they carry today and the loads that they carry today. And that's an important thing to always remember about a local gravel road, that many of them were never designed to carry the modern day traffic. And it causes, I think, all of us that are presenting today to think about all of you that either operate motor graders, are in charge of the maintenance, or elected officials responsible for gravel roads, that our hats are off to you for the job that you do. Just a photo of a gravel surface road that requires some work in the form of some drainage work. When we talk about the factors of a quality gravel road, there are four points that I'd like to briefly go over. The first one being a trained motor grader operator with good equipment. And by trained, it's someone that has had the opportunity to work under someone that is a good operator, or that has went to some motor grader training, so they have a good understanding of what the piece of equipment is capable of doing, how to operate it safely. The other key component is quality gravel. And that's another, you can have the best operators, best equipment, and the best road cross-section, and if you're not buying quality gravel and placing it correctly, you aren't going to have a quality road for the public to use. Proper roadway cross-section, and underneath that a bullet that you'll hear this term mentioned throughout the next hour during this webinar is drainage, 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 and those three terms are one of the key factors in maintaining a good gravel road. The portion that I'm going to talk about this afternoon deals with a maintenance or improvement plan and funding associated with that. Today, when we're looking at a good gravel road, which the photo on your screen shows you, with good crown, good surfacing, good drainage off the road and away from the road, in order to accomplish that quality system, it's necessary that you all think about developing a gravel road or road maintenance program. And I'm just going to go through this briefly this afternoon as steps along the way to develop that plan. I think many of you have probably been in a situation where you're at example, a town board meeting where the public is not happy with the service they're receiving from their road system. It may be not enough gravel, it may be poor drainage, whatever the situation is. And you're in a situation where your level of service is here because your funding is here, and that's really all that you can accomplish with the resources that you have available. If you want to move that level of service up to provide a more satisfied public, it will more than likely take some more funding. And in developing a maintenance program or plan, there's some basic steps to consider. One is to develop some basic standards, road dimensions. What do you think your standard road top width ought to be? What's your level of service, frequency of blading, re-gravel schedule, etc. And then some sort of criteria to rank your current road system. And that ranking, I've seen some scales or some systems that will go from 1 to 100. My recommendation is think about something 1 to 10. It's much easier to get your arms around a 10 scale or even a 1 to 5 than it is a larger range of rating. Once you've established those three items, inventory your roads, assess the condition. That you more than likely you want to take the motor grader operator out with you. You may have a few citizens that want to accompany that process, but inventory of your roads so you can assess what you have for existing conditions and put a rating on those each individual roadway as to its condition based on your rating system. Then talk over what your appropriate treatment to improve those areas might be. And it might be, maybe your focus is going to be you have a poor gravel on the roadways, you don't have enough gravel on the roadways to carry the traffic in the spring. You may have drainage issues you want to look at, but decide what your list is going to include of areas you want to improve on your system, and then what might be the appropriate treatment for those areas. Select the treatment. Maybe it's re-gravel. Maybe it's you've got some frost heave areas in the spring. It may be some tile work. It may be some excavation work to remove poor materials, whatever it is. Select those appropriate treatments. And then estimate the cost of what those treatments may cost your government agency to perform. Now, you can come up with an estimated cost example for a mile of re-gravel at a depth of, for example, 3 inches. Or maybe you've got some culvert work that needs to be done, some poor culverts that need to be either cleaned or replaced. But establish an estimate of those individual costs. Then go about setting a priority list of the maintenance, the maintenance, repair, or improvement items that you want to accomplish over a given period of time. And we talk about improvement plans. We would recommend looking at a 3 to 5 year type program. And when you're preparing your plan, look at one important thing to look at, I think, is what work would you accomplish in that plan given your current level of funding, and if your funding moved up, example, 20%, what items on your plan list could you accomplish with that increase in funding? And that, to me, is key in trying to, when you're talking to your citizens, of if they're not satisfied with the level of service that you're at today, and you can show them a plan that, with an increase in funding, whatever that may be reasonable for your entity, that you can move your level of service from here to here, and funding that associated with that goes to here. I've seen a number of example townships do this in my county and have been successful with it. And it gives you, I think, a position in your, whether you're a maintenance supervisor or maybe you're the maintenance worker for a township, supervisor for a county, whatever entity you work for that's dealing with gravel roads. It always gives you the position of if we want to leave our level of service here, the citizens don't want to provide us any additional funding over here, this is as good as it's going to get. This is where we're at. So from that perspective, it gives you a plan to work from and a plan to explain to your constituents of why we can do this or why we can't do that. Seek approval for that plan, and normally it's a look at an increase in funding from your governmental body to accomplish your developed plan. And I would close in saying, when you go through this process, develop the plan, work the plan. Don't do the plan, put it on a shelf, and look at it 2 years from now. Look at it annually, review it with your town board, your county board, whatever your governing body may be. Take the time to update the plan, what you've accomplished in year 1 or year 2, whatever it may be, and keep them informed. And if you work your plan, you've got a solid plan to start with, I think you'll see a lot of success. First off, in educating the public of what it takes to maintain a gravel road system, and secondly, it provides a basis of information for your governing body to make funding decisions. And I'm going to close my portion of this with a gravel road rule, and John and Corey are very familiar with this rule. More good gravel is no cure for a poor road subgrade or poor drainage. So with that, I'm going to close. Thank you for listening today, and turn it over to John if there's any questions.
Yeah, Rick, we do have one question here for you. This is from Gordon Stinson in Wisconsin.
Okay.
What is the bedding and backfill design for frost taper? Older shallow culverts have frost heaved. What is the bedding, backfill, and slope protection design for outlet on a side slope? Erosion issues at these outlets.
In a quick general sense, I can answer that. It's probably a 10-minute answer if I were to go into detail.
Well, I'll give you 2 minutes then.
I've got 2. Thank you. Reference the centerline culvert if you're looking at culverts where you've got a frost heave. A lot of times that's caused by dissimilar materials. You may have a clay subgrade material and you backfill that culvert with a granular. And so you've got 2 different materials in that road grade at the location of the pipe. A practice that I've used for a number of years is if you're installing a new pipe or repairing a pipe, to backfill the bedding is normally a granular material to bed the pipe. But after you get about halfway up on the pipe, to go back and continue to backfill with the native subgrade soils. It's also important to have a good taper from your pipe trench along the road center line each way to have a very flat taper, probably in the range of 8 to 1, 10 to 1 maybe. You know, some folks even recommend 20 to 1. So you don't have a sharp change in materials. That will go a long ways, I think, to eliminate that in the spring of the year, that frost bump, if you will, or heave at culverts. That might be about 2 minutes, I don't know.
Great. Well, no, that's good. And I think what we'll also do here is, for those that are asking the questions, feel free to contact Minnesota LTAP, and we can follow up with you, and we can connect you with the speakers, and give the email address for them, and they can maybe have some conversation with you offline. I think each one of them would be willing
Sure.
to have a discussion with
and
you.
John and Corey may have some other thoughts on pipe bedding, because it's
That's
a lot
right.
of it's gained through experience over time of what to do and what not to do, depending upon.
We do have an additional question from Paul, and he's asking, is recycled gravel or aggregate considered a quality gravel? And granted, this will be your opinion, but is recycled gravel...
Recycled gravel?
Yeah. Recycled gravel or aggregate?
If you're looking at a recycled material, whether it be asphalt or concrete that would have been recycled, crushed to specification, my experience has been with the crushed concrete, it will set up very well. It's very dusty. I mean, we've used it in subgrades where we've got soft material below as a strengthening layer, I guess, in those kinds of situations. Surfacing, I think, my opinion, it would be tough, very dusty. Crushed asphalt, on the other hand, from experience, I wouldn't recommend use it 100% crushed asphalt. I would blend it with, John commented with probably less than 50% blend, meaning less than 50% crushed recycle. Having had the opportunity to do 100% crush recycle on a short stretch of gravel at one point in my career, I wouldn't recommend it. But about less than 50% blend, I think John is absolutely right there. It makes a great product as a blend, but 100% I wouldn't recommend.
Along those lines, we had another question. What additives can I use to add life or durability to my gravel? And is there a way to mix gravel together with those additives?
Additives, I'm assuming, would be stabilizers,
Correct.
dust control products. I guess my response to that is John has probably got a better background in that, and also Corey.
Okay.
There are many, many products out there, and you really have to, I'm not trying to dodge the question, but I'd like to defer that to probably John and Corey. Many, many products out there. Some are very good. If you're trying something that isn't well known, do a trial, a test strip, to make sure the product lives up to its claims. I would leave that, I think, at that point, Jim.
All right, thank you, Rick, for your commentary from an administrative point of view and a management point of view. Next up, we have John Okeson, who is a retired highway supervisor for Becker County, Minnesota, and he will give you his thoughts on gravel road maintenance design and drainage from a roadway supervisor point of view. So at this point, I would like to invite John up to the podium and share your thoughts. Thank you, John, for coming today.
Thanks, Jim. Okay. Thanks, Jim. Good afternoon, everyone. My part of the presentation is dealing with probably drainage more than anything, probably from a supervisor's perspective a little bit, but just the importance of overall drainage in the road systems. You'll hear this, and I think Rick mentioned it a little bit. The three most important factors in maintaining a good gravel road are drainage, drainage, and drainage. The first part of the drainage equation is your crown, your road surface. To maintain that at a 4% minimum and get that water off your driving surface. The next part is maintaining some type of ditch system. Some of these slides will show not much of a ditch, but it's mainly just a V-type ditch, but it is adequate to take that water off your road surface, move it along your road, and then the last part is get the water away from your road. Some type through culverts, away from the road, in different ditch systems and so forth. Some of the issues we encounter driving around as supervisor, we see high shoulders starting. The best way to eliminate high shoulders is not to let them get started at all. You can see in the slides that there's a high shoulder starting here. It's good material, but eventually that shoulder will keep getting wider and building up, trapping the moisture and water on the road. It will not allow it to get off into the ditch system. There's several ways of taking care of these issues once they get more complex and higher and wider. And through the years' experience, I've used a lot of different equipment. I think a shoulder disc works very well on them, where you disc it in a little ways, let it dry for a day or a few days, then come in and mix it into your surface. Always that material out there has fair binder in it and a lot of good material. So utilize that, especially with the cost today of all our materials. Why not utilize what we have? And then if you have to re-gravel a little over the top, it makes a pretty good graveling surface. As we mentioned, road drainage, a very important factor. This slide kind of shows the start of a poor crown, wide, really wide road that's really gotten flat and out of shape. Doesn't allow the water to get off into the ditch system. Shoulder issues with ditch problem. This is a kind of a complex problem. You got high shoulder, and then there isn't any type of ditch to, once that water runs off the road, to get it away from the road and down into a ditch system. Once this gets this far along, it's more than just a little reshaping issue. We probably got to do a lot of re-gravel, reshaping, get that road back into the typical cross-section that we want it to be at, clean the ditches, and get our ditch system and drainage, complete drainage system back in working order. Just looking at a good shaped road. It takes some time to get your road that's out of shape back into this type of shape again. In this slide, it shows a road that has the outer 4 feet at a steeper slope than a normal crown. That gives you additional shoulder width. And at one time, this road was probably with a 16-foot motor grader. It took us 4 passes to complete that grading on this. Since we reshaped it, got it back in a good typical section, 4% crown. Now we're able to blade that just down and back. I think we all have to look at ways we can cut our costs out there, and with a little additional work at some time, we're able to do that. Just our routine maintenance costs on this road was almost cut in half. It also shows a good ditch system and the water keeping it away from the road structure. We allow the water to sit in the ditches. It will infiltrate the subgrade, and that can lead to frost boil issues and just a soft subgrade. Again, on ditching, here in the wooded area, which some of our roads back in Becker County, which I was superintendent of for quite a few years, a lot of them are up in the forest area. We had to establish some type of ditch system, and good V ditches work very well. Once you get that established, and we did most of this work with just motor grader and a shoulder disc, you can accomplish a lot of good work with just two pieces of equipment. Once we got it shaped, got our V ditches back in so they were operational, then we came back and re-gravelled. Prior to doing this, the road surface did need some re-gravel done to it, so we weren't just going out and spending extra money, but it was a needed maintenance operation that had to happen. Again, on the road drainage, I can't stress enough, proper crown at 4% or probably a little bit more. Once you get under that, if you're down around that 2%, that's typically what a bituminous road crown is. You don't have enough drainage there to take your water off the road adequately. And sometimes of the year, probably later in the fall, you want to go a little over that. I know a lot of the operators prefer that. They do flatten out some during the winter, but that's a kind of a talk to your supervisor and gets his okay on that, and before you go ahead and just do it on your own. Got a few slides here that shows some of our very poor county roads. These slides were actually taken in Becker County in the fall in the ag area. A lot of the damage is caused by the farmers in the wet fall, sugar beets, our big dairy farm operation where they got to go out and cut silage. This typical section here of this road has really gone out of shape. The water is trapped on the road, lack of good gravel, and as some of these slides will show, even our ditch system has been plugged. Again, no crown, lack of good surface gravel, and also you can see the stuff that's been pushed over and into the ditch system. This will not allow our proper drainage in our ditches. Also with the drainage, we have to maintain our culvert system. What I like to do is in the fall, late summer, fall, have your grader operators make a list. Keep track of where there needs to be some work done before it frees up in the fall. This type of situation happened where a culvert was actually filled with material. It froze, and then you start getting calls from the farmer in the spring of the year. He's waiting to get in the field, and we're flooding his fields. Big issue. So, and it costs a lot less to go out and maintain these areas late in the fall before freeze up. And I always relied very heavily on our motor grader operators to feed me that information. They're the eyes and ears out there every day going up and down these roads. As supervisors, we don't have time to cover all the miles of road once or twice a week. So, kind of concluding here, again, drainage is one of the key factors in maintaining your gravel road system. Keeping that water off your road surface with adequate, like 4% crown, keeping those ditches and culverts clean. And once you get that water flowing in your ditches, try to get it away from your road surface. If we can maintain the integrity of our road surface, it will sure help the structure of that road, and especially with the increased heavy traffic we're dealing with today. Like Rick had mentioned, most of our gravel roads were not designed for the weight that they're receiving today. With the larger farm equipment, more manufacturing being moved out in a little bit of rural areas, and just our day-to-day normal graveling traffic out there. Bigger trucks, more weight, creating more issues for us. But if you can maintain good drainage, it's going to help you in the long run to maintain your gravel roads. That's all I have. Thank you. Okay.
All right, John, we do have a question here. Is there a minimum % crushing you would recommend for a material being added to an aggregate surface road? So again, is there a minimum % crushing you would recommend for a material being added to an aggregate surface road?
Well, the way I'd look at that, if I'm adding it to a gravel on a road, I want to know what type of material is out there to start with. I've always taken a few samples, we've done gradations on that, and then I determine what % of crushing or what % of binder we have to add to the material to make a good road surface. And I think that's where you have to start. Have some idea of what you're adding it to.
Are they asking if can you use just screen gravel?
Screen gravel, still you want to know what you're adding it to out there. Typically, I think, Rick, correct me, but if we're crushing new material, we want about 25% crushed material in there.
25 to 30.
Yeah. So that'll be new material.
All right, we do have another one here. Bear with me as I go through. It's a specific question. It's from a person, I believe, in Franconia Township. 1 year ago, we added 4 inches of good gravel to an existing roadway. It contained some recycle, was rolled or compacted, and has held up well. However, now it needs to be graded. Our operator seems to be afraid to do more than scrape the top. We are left with puddling in the middle of the road versus a good crown that helps disperse the water. What is the best way to handle this situation?
Corey will probably comment on that too in his little presentation, but what I would do, there's different types of cutting edges out there that I would start with. And what I've done on a situation like that is use a carbide tip blade on the motor grader. You're going to have to reshape that road top, take a couple of inches loose, get rid of those potholes, get rid of any washboarding, and kind of redo that top. If you just let it go, you're going to lose more crown, get more potholes, and more. You're going to lose your whole cross section of that surface.
All right, thank you, John. All right, we have another one here. I am a research road engineer in the Forest Road Engineering from Innovations, Montreal, Canada. My question is, in the long term, what would be the plans to try to convince the road administration that investing right now on the road design, using a great backfill in your subgrade soil, would be more cost efficient in the long run? Most of the companies who own these roads or have the responsibility to do the maintenance always seem to invest as low as possible to maintain their roads. And for example, they would never consider bringing a better quality gravel from 100 miles away when they can use the materials on site that would not last for a while. However, economical analysis has proven that bringing in quality materials might be expensive, but will be more beneficial in the long term. So how can I make that sell? How can I make that point, to those making the decisions?
I think over the years, probably in our gravel classes we've done, we use a factor on different types of material and actually put a cost to them. And cheaper gravel is not the good gravel. The good gravel is going to cost you more, but you're getting more life out of it and actually cost you less down the road. It's hard to convince some of your financial decision makers that's the way to go, but I think research and just a lot of good old experience out there shows that we got good material. It's going to stay in place better, give us more serviceability, and the traveling public are going to like it a lot more.
So you mentioned in your answer that in your gravel roads class that you do some economic analysis, a little bit of that. Is that something that they could contact you? I mean, is there some formulas that you guys use that kind of assign this value to help make that decision?
Yes, there is, and you can inject whatever unit price you're dealing with in your areas because they're all over the board, but there's percentage factors and stuff we put on just a pit run material, a screen material, and a good crushed road gravel.
All right, so for the person that did ask that question, I encourage you to follow up with
That'd be
us
fine.
here at Minnesota LTAP, and we could maybe get you some information on how to make that decision. We have one more person that wants to add an answer. You need to use the...
This is Rick. Just a comment or a thought going along with what John said. One thing you might consider if you're trying to sell the idea of a better quality gravel is work to the idea that maybe let your bosses, if you will, if that's the right term, try a test section. Maybe try a half mile of a good quality material and just let them see what the benefits of that are. More of a just a hands-on, on the ground sort of demo project. That might be helpful too.
Yeah, and another note on that too, if anybody's interested in what we consider a good quality gravel here in Minnesota, they can contact myself or LTAP or Rick, and we can give you like a Class 5 modified spec that would work real well, or a Class 1. And most states has something that conform fairly well to that.
All right, the last question that we have right now at this time is from Jeremy. He's asking, are there standards for a V-ditch? You mentioned a V-ditch in your presentation. And are there specific dimensions or?
No, not really any standards. The slides that I showed, a lot of them are in a wooded area, so rather than encroaching back into the trees and taking out trees and making it a huge project, we just used what we had. It was probably, once you're done, the top of the V-ditch is 2 to 3 feet wide, probably 1.5 feet, 2 feet deep. Whatever you can put in place to take care of the water. If you got a little bit more room, you can go with probably a 2-bottom flat ditch. It's a little wider top. And that's only if you have enough room to establish that.
All right, and I think as you were speaking, we got one more question. Do you personally have a preference on aggregate type, limestone versus granite versus a pit material, etc.?
I have limited experience with limestone, but it's a soft rock. I'd rather go with your harder aggregate granite type materials that meet our specifications. It's going to last longer. Limestone has a tendency to grind down under traffic, and certain limestone, when it gets wet, can get fairly slippery.
And granted, I think you're speaking from your experience here in Minnesota. Obviously, people across the nation that are listening to this are going to have to rely on the product that they have at their availability.
That's correct, Jim. All different areas have a little different types of material that they have to work with. But
all right, I think that ends the questions for your section, John. Thank you.
thank you.
As we are bringing Corey up to the podium, I want to just make a couple of comments here. Some of the products that Minnesota LTAP has to support this webinar is we have a online gravel roads class that's currently available on our website. It's a class that's $40, and it's 10 modules that people go through the modules. They read information, they watch videos, they look at photos, they take some quizzes and do some exams, and at the end you get a certificate of completion for an online gravel roads class. Again, it's $40 offered through Minnesota LTAP. Then we also have an online gravel road DVD. Our trainer, John, that you just heard from, and I believe Corey, who you are going to hear from, uses our gravel road DVD as a training tool in their classes. The DVD is called Gravel Road Meeting the Challenge, and it's about a 12-minute DVD that has animation, live footage of how to properly maintain your gravel roads, how to operate your motor grader, and how to prepare and look at the different types of gravels needed for your roadway system. So those are just a couple more plugs for some products that LTAP has. At this point, I would like to bring Corey up to the podium. Remember, Corey is our heavy equipment operator. He's also the instructor for our gravel road motor grader equipment training class. So, Corey, welcome.
Thanks, Jim. Good afternoon, everybody. I'm Corey Urich. Glad to be here. Glad everybody else is here. I always feel young when I'm around these guys. They've been at it about as long as I've been alive. But for some reason, I'm going balder. I don't understand it, but anyway. The portion I'm going to go over today is something that might help some supervisors or different operators. Just checking for some proper grader operations, some ways that you can look and see if they're doing it right. You know, that's a lot of questions I get. How do I know if they're doing it right? Because a lot of times the supervisors have never sat in the seat in this day and age, and they're wondering how do I know? You know, aside from the complaints from the public. One thing on this first slide here is to look for is angled washboards. If washboards are caused by traffic, they're usually straight across here. This look here, when you see the angled washboards, when you drive by your motor grader operator or watching what they're doing, you'll see that those washboards will mimic the angle of their moldboard. And the moldboard is a part of the blade that is actually cutting the ground. And what will happen if they get going a little bit too fast, they'll get a little bump going. Sometimes to eliminate that, you know, maybe they need to stagger the air pressure in the tires, you know, articulate the grader slightly to eliminate that hopping motion. They can go a little faster. And another thing to look for is if that motor grader hasn't been properly maintained, all the knuckles and joints that haven't been greased, and the slide, the wear plates, if they're not tight, that motor grader will have a lot of slack into it, and it'll get that hop into it. So that's some stuff that's an easy check. And regular washboarding, you know, that could be caused by lack of moisture, hard acceleration by traffic. I did some training next to a farm, and they had large equipment, and you could actually see where the trucks were downshifting, you know, in their pattern for each sign because the washboards would start and stop. And, you know, just aggressive braking or just having poor quality gravel can cause that washboarding. We had a little talk earlier about, you know, recycled asphalt. I see that a lot with asphalt. People will get a little bit where they're milling, put it on an intersection. It washboards up right away because there isn't enough binder and it doesn't have the right mix. So it looks hard and crusty, but then it falls apart pretty quick. You know, to prevent the washboarding, what I like to see is people to scarify or undercut the washboards. There's something I promise I didn't make up this word, but it's called differential compaction. If anybody's been involved with asphalt, you know, if you want an inch of asphalt, you have to put 1.25 inches down. Same thing with gravel. If we just take this gravel and do a maintenance pass and just cover up these washboards, if they're a 2-inch divot, the next day you'll have a 1/2 inch divot there, comes right back. So you'll want to scarify them or cut them out completely, or, you know, have somebody packing behind you. So that's one thing there. The correct slope, you know, to check that on a road. I know we've been talking in percents. I like to talk in percents, but the average guy out there, he doesn't understand what we're talking about when we say 4%. We're just talking about the drop in the road. 4% in 10 feet, you know, is 0.4 of a foot or 4.8 inches. 4% in 12 feet, that's 48 hundredths or just under 6 inches of drop. And really 4%, it's a 1/2 inch per foot. You know, so that's something to think about. There's different ways to check that. I mean, a lot of counties will have a survey crew. They could go out and do a couple of spot checks. A little later on in the presentation, I'll have a picture of a slope board you can use. I've seen guys take a small $20 laser pointer, put it up on the crown of the road, and take a shot of it on the side. Lots of ways you can do to check it, but that's what you're shooting for. And like John mentioned earlier, paved roads are typically shooting for 2%, so your gravel road should be twice as steep as most of your paved roads that you see, because they are gravel. A slope meter, this brand right here is actually made in Minnesota. If you are using these, make sure you have the percents. There's another slope meter that looks almost identical. It has more of a cup to it, and that's more for slope ratios. It'll, instead of it going up to 12, it'll go in reverse, like 2, 3, 4, 5, 6. And that's for doing like a 4-to-1 slope ratio in a ditch. But this one here, each little divot over is a percent, and they're really easy to install on a motor grader. So all your motor graders should have a slope meter in them so they can see what they just did, and it measures what you're just doing. And as a supervisor, you can install those right in the dash of your pickup or somewhere in there where you can see it. And just to check it, all you do is you set it up, mark your tires. If it says 2% one way, do a 180, park in that same spot, and it should say it's 2% the other way. If it says something different, you just adjust it so it stays the same. And you can actually drive down the road after your operators are done working and see what they're doing, and be able to inspect them that way. I've seen guys get smart levels and put them on their dashes. The only thing is, and that's just a digital level that you can put in percents, but you actually do have to stop with those because it's moving too quick. With these, it actually, you can be moving while you're doing it. You just watch on the curves. If you're going too fast, it'll swing that bubble around and it'll give you a different reading. But easy to use, 100, 150 bucks, good investment. One not to have a crown or transition to one spot is a transition to a super elevation. So we've been talking about a typical gravel road with a 4% crown. Now if you've watched NASCAR races, where they have the bank curves, as we go into these curves, it's called a super elevation. So what I do is I leave the bottom side the same, and maybe depending on the speed of that curve, maybe 100 feet back, I'll start jacking up the high side a little at a time. So when we get into the full super, we're like this. If it's a higher speed curve, then we'll maybe change it to maybe a 5, 6, more of a percent, just depending. And then as you come out of it, you just slowly crank down the high side. That's important for, in the wintertime in Minnesota. Imagine that NASCAR race where if it was banked the other way, the cars would go sliding off. That's what happens in Minnesota here in the wintertime. The cars just go flying off. One way to inspect that, if they are built properly, the traffic whip from going around those super elevations will make them too steep, if they're built right. So the gravel will actually naturally go up, and the operators actually have to pull it down. When they're built incorrectly, the operators actually got to pull it up the other way. So that's something to look for. But that's when not to have a crown. This picture here, this road has a nice curved super elevation. All the water is going to sheet drain across to this inside, so you got to make sure you have your drainage going, because that water's got to go somewhere. But there is no crown here, and again, that's a safety deal. Another place to stop crowns is coming up to railroads or bridge abutments. Obviously, that railroad is going to be in a straight line, so maybe 100 feet back, you start warping out of that crown so that when you get there, you're flat. And just make sure that that flange is clean on that railroad, because you don't want to cause a train derailment, by pulling gravel up on there. That's another instance of where not to have a crown. Talk a little bit about intersections. The primary road should retain its crown. So if you've got a thoroughfare here with no stop signs, they should maintain their crown. And the controlled sides should have stop, and they should match the shoulder of that intersection, so that when you're driving through these intersections, if you're on the thoroughfare, you shouldn't feel this in your car as you go through those intersections. The stop signs, they're stopping, and that's another safety hazard. If you're driving down the road and you're doing this all the time, when it's icy up here in Minnesota, you could have an accident. So that's something to check for. Uncontrolled intersections, that's where nobody has a stop sign. With uncontrolled intersections, the ones where you yield to your right because, you have to watch for traffic, the actual intersection should be flat. Everybody should warp out of their crowns and meet at the shoulder of all four sides. The only thing is you got to make sure that intersection isn't low, because it'll be a big bird bath. that intersection should be elevated so it does have some kind of drainage. Shoulders of pavement, you'll want to make sure that you match this shoulder. This should be flat again, so as you come from this side here, about 100 feet back, you start warping out of the crown so that when you get here, you match the shoulder. We want to be very careful not to drag any aggregates out onto the pavement because that causes a braking issue. You know, you have gravel under your tires and you can skid out into the intersection. And the easiest way to maintain these types of intersections is they're easy to tell if your operator is doing it wrong. He'll always start here and he'll go this way, and so he'll fill up his blade and take it with him. And then when he comes back at the end, he'll dump what's on his blade here, so the one side where he stops will be higher than when he starts. So what I do is when I come back, I just swoop across and fill in where I started from. Maybe I have to do a little back blading, that sort of thing. But just another instances where you should not have a crown. Driveways, entrances. As you're going down this public road, this is the public road. This is your farmer's driveway or entrance. A lot of times you'll see these getting pulled way out because maybe the farmer is dragging his road or getting gravel from the public road and pulling it up his driveway or vice versa. But as you're driving through this public road, you should not fill those driveways as you're coming through. And it just takes a little time. You know, operators out there or supervisors, don't gouge them all out at once, just a little at a time and start fixing those things. And again, if for snow removal, when you're set up and you got your blade set up for plowing snow, if these slopes are constantly changing and you have these driveways, you're going to see a lot of gravel in the ditches around these areas where they have to change to match the road. They should be staying the same. And here's just a look at that slope meter and a slope board. If you've seen an asphalt paving crew, they'll have a slope board where they're checking the gravel with that board that's 10 feet long. You just set it on the grade. This style here has an actual bubble in it. I take these, I attach a slope meter right on it. I can set it down and I can check to see if the mold board is out of whack or not. And you can actually show the operator how much they need to change. So very inexpensive thing to have, but a good way to check your grade. And you get visual proof. You can show your operator, hey, this is what you're doing wrong. And what's nice about this slope meter, since we're talking in percents, if it's 1% off, that would be a tenth, of like 1.25 inches and 10 feet. You know, so that's something that you can raise that up and say, this is what this should be. Another thing with the slope meters, that tells you what you just did. So the one up here says it's 0. If I wanted to go to a 1%, if I cut that 5/100ths on one side, nothing in the middle, and fill 5/100ths on the other, I've just gained 1%. You know, so it's small increments. It's not very much. Blade position. This picture here is just if you look at the toe of the blade. If you don't have 30 to 45 degrees of blade angle, what happens is as you're pushing the gravel along, it's shoving instead of mixing and reincorporating with the fines and getting pulled across the blade. If you just think of a motor grader, it's designed to carry material from the right to the left. It's not really designed to carry it forward. So if you've got the right blade angle, you're going to mix that gravel back up and get it re-blended. Every time you touch gravel, it causes segregation, so you're trying to fix that from the traffic causing the segregation. Just to determine the correct moldboard, most people out there are using a 16-foot moldboard, you know, so that you can actually have the right angle and blade that 12-foot wide path. You know, some places maybe they have a 10-foot top. Most of your roads have a 12-foot top. So if you only have a 14-foot moldboard, if straight across at 30 degrees, you'll have 12.1 feet. With a 16-foot moldboard, you can actually have that at, you know, about a 40-degree angle and be almost at 12 feet. And what I do is I just notch. I get it set up. When I do my motor grader training, we'll set it up so it's right. I'll put a little notch right back here so that from the cab of the machine, the operator can look and see where that 30 or 45 degrees is. And then he's almost got like a homemade jig as he's blading. He knows he's making a 12-foot pass. Now, I think that's important because why would you be blading where cars aren't driving all the time? You know what I mean? You're overworking. So, you know, you can pull up your shoulders, tighten up your road so that you have the right widths on top and actually have less work later on. And again, just to piggyback on that, mixing action is part of routine maintenance. you're either part of the problem or you're part of the solution or part of the problem. So a lot of motor graders, nobody's ever told them about gradations and mixing gravel and what that binder's doing. So the picture to the left, this road's had the right moisture. The gravel's been mixed up. It's been laid down. It looks like you can almost rollerblade on it. If you look at the picture to the right, there's a lot of float, and that's what we call that material that's sitting up on top of the hard surface. That's all. It's not really doing anything for you. It's just sitting there. If you fill up a pothole with that, the next car that hits it just pops it right out. So part of that blading action is taking this, mixing it with the fines that have washed out of it, getting it reincorporated and laying it back down so you have a good surface. And the motor grader mold boards typically wear in the center pretty rapidly. So this next slide here is just a picture of a parabolic crown. Now I think, you know, seasoned is the correct word for John and Rick. You know, years ago they talked about parabolic curves, you know. I live in a town where they still do parabolic curves all over the place, and I don't understand why. And that parabolic curve, instead of just straight lines, it's kind of a curve. And it's really hard to do snow removal because you can't ever really cut down. But that mold board, over time, it'll get that parabolic curve into it. So as you're blading, the middle part here will be pretty flat, and then it'll cut and cause these high shoulders on the sides. So it's just something to watch. Switch them around. Just have your operators maintain their cutting edges. One way to get away from that, this next slide is just different types of, you know, cutting edges that you can have on your motor grader. This is a carbide faced cutting edge, and this slide says this is what it looks like after 650 hours. They're expensive on the front end. They might last longer. You can move them around a little bit. I've seen them where these actually, if you have a rocky stretch of road, where they'll pop off. For questions or minutes? I think we're getting close to the end. This is looks at some replacement bits, different examples. And again, trial and error, you know, get some. Maybe you can have a supplier give you some at a discount to use and try out. When you do use these bits, they're designed not to cut windrows with. They're designed to run almost a straight blade because that bit, the way it's set up, it's going to mix anyway. So disregard the blade angle that I talked about earlier when you're using bits. But if you are putting up windrows, it'll actually cause more damage to the road because you're going to loosen up the grade more than you need to. So it's something to think about. And they are designed to go at a specific angle. This manufacturer, this style I have up here on the board, is designed to run at a 20 degrees back from vertical here. So just get with whoever your manufacturer is. Make sure they're using them right. And again, you've got this carbide tip here, and it doesn't do you any good to drag that along, and you hit a rock and you lose those carbide bits. Roller use, the slide I have here is a pneumatic roller. What that does for you is it kind of kneads the gravel back. You get compaction that way, and it seals it up. When you just pack with your tires, you're not getting uniform across the grade, and you can actually cause more ruts later on when you aren't using rollers. So if you have them, use them. If you don't, they're fairly inexpensive to get. And the last slide here is just before you add new gravel to a road, take a little time and do some pre-shaping. As you can see on the slide here, if we just take and add 3 inches to a road that's got no crown and it's flattened out, we got plenty of gravel in the middle, nothing out on the sides. If we take a little time and pre-shape it, we get a nice uniform top, get a nice crust, and it'll hold up a lot nicer. And that's the last slide I have. Is there any questions?
I guess there are no questions for you, Corey, so you covered everything the way it should be covered. So thank you.
Appreciate that. Thanks, guys.
At this point, it comes to the end of the end of our webinar today on gravel road maintenance. A couple of things that we'd like you to consider. Please contact Minnesota LTAP through our website and let us know if you want to follow up with any of the instructors today. They'd be happy to get in touch with you offline to discuss gravel road ideas and strategies with you. Also, we do have some other webinars again on our website. One is on ADA compliance and how to make a transition plan for your community. And we also have a webinar on local concrete flatwork specifications and what they are and how to use them in your construction projects. And last, I'd like to encourage you to email us maybe some topics or ideas that you would like to hear on another webinar. We are trying to move forward with webinars over the next year or so, so we'd like to hear your input on what would be a good topic for that. Thank you again to our speakers for your contributions today. We appreciate that. And with that, let's say have a great day from the University of Minnesota and enjoy the rest of your day.